Okay, so for this unit, we're starting in the trigonometric ratios and angles. So we're going to be looking at special triangles for activity 2. Now, you're going to apply your sine, cosine, tan ratios, which are your trigonometric ratios, inside of a unit circle. So you're going to have to remember these special triangles. Now, this triangle here, as you saw in the diagram from your note, can be just written as a regular 90 degree, just because there's two 90-degree angle triangles here. If we put 30 at the top and 60 at the bottom, so you can just look at this triangle in order to help you. Sometimes looking at both triangles is a little confusing. So this is one of the special triangles that you will need to know and memorize. The second one is this one here. These are the most common angles that we work with in unit circles. So those are the two that are given to you and those that you need to know. Don't worry too much of how they came about, but you just need to know that you're going to be using them for the unit circle. Now, what is a unit circle? I sort of defined it at the top of your content. A unit circle is when your radius, so from the center of your circle to the edge, so anywhere from the center to the edge, is equal to 1. And I know that it's equal to 1 because if I go from the center right up until it hits the side, I know that this coordinate is 1, 0, which makes the length from here to here 1. And a radius is the length that goes from the center to any side of the circle. And if this one is 1, that means that any radius will be 1 as well. So hopefully you remember that from prior lessons. If not, it's kind of explained right here. So we're going to explore some of the functions that sine 30 is going to do. And we know that sine of any angle will be the opposite over the hypotenuse. So in this case here, if I go to angle 30, which is right over here, I'm going to go to the opposite. So this is my opposite right over here, and then I'm going to go to my hypotenuse. Well, the hypotenuse here is basically the radius. So it's going from the center to the side of the circle. So I'm going to rewrite this as sine of 30 degrees equals opposite over the radius. Now I'm also going to rewrite my opposite as the actual values in my triangle. So from angle 30, my opposite is A to F. So I'm going to rewrite that as AF, and I'm going to rewrite my radius as AB. So just know that there are a couple words that you can use for the hypotenuse side. It could be AB or it could be your radius. However, for the opposite side, it has to be called just AF. So we now know that the radius, because this is a unit circle, the radius is equal to 1. So we're going to go ahead and where R is, or where AB is, we're going to substitute the value 1. So we have AF over 1. And we know that when we divide anything by 1, it just gives us that value. So right here we have sine of 30 degrees equals just AF. If you go ahead and evaluate on your calculator the value of sine 30, you're going to get a certain value. And that value will be sine of 30. Again, make sure your calculator is in degrees. So I'm just going to make sure I go in mode and my calculator is in degrees. So I'm good here. I press enter. Oh, it's equal to 0.5. So I know that sine of 30 is equal to 0.5, which means that AF is also equal to 0.5. If you look on your diagram, however, it's only the point A that is equal to 0.5. If you follow along for the y-coordinate, the y-coordinate is equal to 0.5. So that is very, very important to note that it is just the y-coordinate here. I'm just going to write that down. The y-coordinate is equal to 0.5. So now you must be wondering, well, how do I find the x-coordinate? Well, I can't use sine because sine is only going to help me find the y-coordinate. So now I'm thinking I have to find the x-coordinate, which is right over here. And this, according to angle 30, is my adjacent. And with adjacent and the hypotenuse, since we know that the hypotenuse is my radius, which is equal to 1 because it's a unit circle, with the adjacent and the hypotenuse, I'm going to use cos. We're going to go ahead and work from the same angle, from cos of 30. So we're just going to write down that cos of 30 is equal to the adjacent over the hypotenuse. Now again, we know that the hypotenuse, which is from the center of the circle right up to the side of the circle, is also your radius. And your radius is equal to 1. We don't know the adjacent, that's the x value, so that's what we're looking for. So we're just going to go ahead and write that cos of 30 equals the adjacent over 1, because my hypotenuse, or my radius, is equal to 1. So now a divided by 1 is just a, and we know that the adjacent is from b to f. So I'm just going to go ahead and change that. It's from b to f. And b to f is the x-axis, so that's how you're going to find the x-coordinates of this problem. So we're going to calculate cos of 30. Now cos of 30 is equal to approximately 0.86, I believe I saw. 0.87 if we round it off to 2 decimal places. So that's approximately, which means that BF is also equal to 0.87. If we check that, now if we go to coordinate F, because that's the one we're looking for, 0.5 is right here, 1 is right here, so 0.87 looks like it could make sense. Okay, so this is what BF is equal to, but really this is just the x coordinate. So we're going to write that down. The x coordinate is approximately 0.87. Okay. So what I need you to remember is that the sign is going to help you find the y coordinate. So I'll just write that out for you. The sign will help you find the y coordinate, and the cosine will help you find the x coordinate. So that's what's important to take from here. Now, in the assignment, they're going to ask you to find the exact values. So you're not going to be able to give me 0.5, which is what we found over here, and you won't be able to give me 0.87, which is what we found over here, because we have the special triangles. So if I go back to those special triangles, that's where you're going to have to work and to find the exact value. The special triangles that we had, just going to roughly sketch them. You're going to have to draw these quite often, so get used to it. So you've got 30 at the top, 60 at the bottom, you've got your square root here, and then your 1 and your 2. You also have the other special triangle that deals with the 45-degree angle. Okay, so we have 45 degrees here, 45 degrees here, 1, 1, square root of 2. The only way to know this really is to memorize it. There's no other great way to know this, unless you write it down on a separate piece of paper, and that way you can always have it, so you won't have to redraw it all the time. So if I go back here, we were trying to find the y value, and we know that it's equal to 0.5, but I want an exact value. So within the angle we were working with, that was 30 degrees. So I'm going to go look at my special triangles and find where I can see angle 30. And clearly, it's going to be this one, because angle 30 is right up here. Okay? So from angle 30, I said that the y coordinate is found with sine. So again, I'm just going to go ahead and redraw that. Again, I said you're going to have to draw these often. Okay. From angle 30, so this is the angle we will be working from, this one right here. Okay. We're going to do the sine to calculate the y value. Okay? So x is the cosine of angle 30, and y is the sine of angle 30. So from here, we're going to go ahead and calculate the sine of 30. So sin of 30 degrees equals opposite over hypotenuse. Sine of 30 degrees. Now from here, your opposite is 1. And just going to write that down, and your hypotenuse is 2. So you're going to write 1 over 2, which is your exact value. I don't want you writing 0.5. When I ask you for the exact value, I'm looking for 1 over 2. So here, I'm going to have for the y coordinate, yet again, because we use the sign, it's going to be 1 over 2. We're going to go ahead and do the cosine of angle 30. We're using the same triangle because we're still working with angle 30. So equal to adjacent over hypotenuse. I'm going to go ahead and label my adjacent, which is square root of 3. Now my adjacent is square root of 3 over the hypotenuse, which is 2. Now, that's what the cosine of 30 is equal to, and this is the exact value. This is what I want to see in your coordinate. Now, if you are actually going to calculate this in your calculator, you will see, show you here, that when you do square root of 3, so square root of 3 divided by 2, that gives you 0.87. And when you do 1 divided by 2, it's 0.5. So just remember that these are my exact values. That's what I will be looking for in the assignment. Now you're going to have to note that in the first quadrant, okay, so when we have quadrant 1 over here, we have quadrant 2 over here, and quadrant 3, and then finally we have quadrant 4. In quadrant 1, all x and all y values are positive. However, in quadrant 2, the x's are negative. So here, we've got negative x values, however, my y values are still positive. When I head out into the third quadrant, my x values are negative and also my y values. And then quadrant 4, my x values are positive and my y values are negative. So that's why you'll see within this unit circle, now I know this is very confusing and this actually takes a lot of work to get to. We only found this part right here in what we just did. So I want you to notice that cosine is always first and sine is always second. So the cosine of angle 30 that we did was square root of 3 over 2, and the sine of angle 30 was 1 over 2. Now if you're using the 45-degree angle, you cannot use the same triangle. You're going to have to use the triangle that deals with the 45 degrees. So I'm just going to draw that real quick. 1 square root of 2. Remember that cosine is first, so we can go ahead and do cosine of 45 equals adjacent over hypotenuse. Cosine of 45, we have to label our sides. So from 45, I'm going to use this angle here. Doesn't really matter which one you use, they are both 45. My adjacent is my 1. My opposite is also 1, and my hypotenuse is square root of 2. So my adjacent will be 1 over my hypotenuse, which is square root of 2. So the x value for the 45 is, okay, so as you notice here, it doesn't quite look the same, but we found that the coordinate for the x would be 1 over square root of 2. This is correct. Just that some people tend to not want a square root in the denominator. We're not going to worry about that. These are the same things. It's just that they made extra operations here. So don't worry about this part here. Okay, we're just going to work with 1 over square root of 2. Now to find the y value, so this was the x value. To find the y value, we're going to go ahead and do the sine of 45. So sine of 45 is equal to opposite over hypotenuse. Your opposite is equal to 1, and your hypotenuse is equal to square root of 2. So we've got 1 over square root of 2. So this is the right thing. So here's another unit circle that I found. This one is the correct one that you would be using without having to change your operations. So just make sure that you use the appropriate special triangle to find the exact values. If it's 30 or 60, you're going to have to use the 30-60 one. Now, when you're going for 120, you're going to have to realize that 180 minus 120 is 60 degrees. So this one here is the same as 60 degrees. 135 is the same as 45. 150 is the same as 30. Now, the lines all match. So it's the first line to the first line. First line, first line. 330, 210, 150, and 30 all go with a triangle that deals with the 30 degrees.